So the next one is metal olefins. So metal olefins are the organic molecule is attached to a metal via pi electrons of the ethylene ligand, so that complex are said to be a metal olefin complex. So the example is this salt. So this salt, so the first organometallic compound, an alkene complex with the formula, so that is potassium trichloroethene platinate 2, was synthesized in 1827 by this a Danish pharmacist. This was obtained by him a pale yellow crystal by reacting ethyl alcohol uh, with uh, potassium chloride. During his period, the theory of coordination chemistry has not developed, and therefore this compound remained a mystery. With the development of this theory of the coordination compounds, this compound was re-investigated and its structure understood. It can be prepared also from ethene and interact with the potassium chloroplatinate. So it is, so potassium trichloroethene platinate, that platinum will exist in +2 oxidation state. So the structural feature of this salt, that is platinum ion in the salt is 4 coordinated, that is square planar with 3 sides occupied by the chloride ions and the fourth side by the ethylene molecule, fourth side, and its geometry is square planar. The pi electrons in ethylene are coordinated to the platinum. Then the length of the coordinated alkene, that is carbon to carbon, is 1.375 angstrom. Is greater than the C double bond C, that is a free ethylene molecule, that indicates it is somewhat involved in the bonding towards the platinum. Then the carbon to carbon double bond is perpendicular to the molecular plane, so which you can see in the structure. The metal is located above the plane of the alkene, symmetrically between two skeletal carbon atoms. So the carbon atoms are almost equidistant from the platinum of ethene. Then the water molecule present in the salt is not attached to the metal, but it is accommodated in the lattice as a solvent molecule of crystallization. So we can see, so the hybridization of the ethylene here. So in the hybridization of the ethylene, the hybridization is sp2. So one, that is pz orbital, is empty here. Then it will undergo hybridization. Then we can get an empty antibonding molecular orbital. So one antibonding molecular orbital is empty because that is pz orbital is empty, so it will interact, that is LCO, linear combination of atomic orbitals, lead to the formation of a molecular orbital. Then the molecular orbital is 2, bonding molecular orbital, antibonding molecular orbital. Bonding molecular orbital is filled, antibonding molecular orbital is empty now. So we can see how we can get that one. So here, that is antibonding molecular orbital is empty. So pi bonding molecular orbital, it is having a 2 electrons, so here it is empty now. So ethylene contains a empty antibonding molecular orbital. So this makes very active organic ligand, that we can see in carbonyl also same. So why that ethylene accept a pair of electron from the metal ion? That is due to the empty antibonding molecular orbital. So that is metal olefin bonding, that is olefin ligand having sigma bond formed due to the overlapping of the sp2 hybrid orbitals of the 2 carbon atom with pz orbital of the 2 carbon atom overlap to form a pi bond and a pi star antibonding molecular orbital. So as earlier we can know the hybridization of an ethylene, we can get two forms, pi bonding and then pi star antibonding molecular orbital. The pi bonding molecular orbital is occupied, where antibonding pi star molecular orbital is vacant. The occupied pi bonding of the alkene overlap with the vacant sigma orbital of the platinum, then produced a metal ligand sigma bond. So we can see this type of bonding in metal carbonyls. Metal carbonyls also has having a sigma bond, because a ligand will donate a pair of electrons to the metal ion, lead to the formation of a sigma bond. Here also the same. Then in additional, a pi bond originate from the overlap of a d pi filled orbital of platinum, which is not used in the bonding, with the empty pi star antibonding molecular orbital of alkene. As already we know that the pi star is empty, then the metal will donate a pair of electron, then ethylene will accept that one, then lead to the formation of a pi bond. Thus the metal alkene compound consists of two components. One is sigma donation from the ligand to metal and pi donation from metal to ligand. The metal carbon bond in the similar to the metal carbon bond in metal carbonyls. Both alkene and CO are very weak sigma donors, but the presence of low energy empty pi star molecular orbital of this ligand makes T pi 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 to pi star bonding possible. The transfer of electrons from ligand to metal during the formation of the sigma bond is enhanced by the simultaneous removal of a charge from the metal through d pi to pi star back donation. So this is also known as synergetic effect, or what we are discussed in the metal carbonyl. Once again, this makes a compound stable. So why organometal compounds are stable means due to the presence of two types of bond on a sigma as well as the pi bonding. So here also we can see how that sigma bond has been formed, that the movement of an electrons from ligand to metal, and then how pi bond has been formed, that is movement of electrons from metal to ligand. Also we can call it as a back bonding or synergetic type of an effect. Then what is the importance of these ornamental compounds? That it will act as a catalyst. So catalyst is a substance that increases the rate of the reaction but it not itself consumed. The catalysts play a vital role in the production of the fuels, commodities, fine chemicals and pharmaceuticals, as well as the providing, that means experimental safeguard all over the world. So more than 60% of chemical products and 90% of the chemical process is entirely based on the catalysts only. A whole new technology appears based on organometallic catalysis in olefin polymerization. So the best example is polymer like polythene. So how we are going to get that polythene with the help of an ethene, that is by the help of an Ziegler-Natta catalyst. So Ziegler-Natta catalyst, it is a mechanism where it will combine two ethene molecule to form polythene molecule. So